Hello, and welcome to Math Blossoms, where growing in mathematics is natural. Today's lesson topic is multiplying and dividing fractions. Let's get prepared. You're going to need a pencil with an eraser for today's lesson, a piece of paper to take notes, and a calculator is optional but not required. Don't forget to pause the video from time to time to answer the practice questions, and rewind the video if you need to review anything or if you just need to study. Okay, so let's grow our vocabulary. But before we do, I'm Miss G, and we're going to start our lesson today by doing 3 deep breaths, so deep breathing exercises. We're going to breathe in our nose. We're going to hold it for a count of 3 and then breathe out our mouth. Okay, and we're going to do this 3 times. So as we breathe, we're going to try to forget all the little thoughts that might be jumbling up around in our heads that might get in the way of our learning. So let's breathe in our nose. Hold it for 1, 2, 3, then breathe out your mouth. Okay, second breath, breathe in. Hold it for 1, 2, 3, then breathe out. Okay, third breath, breathe in. Hold it for 1, 2, 3, then breathe out. All right, now let's look at some of these vocabulary terms we're going to be going over today. First one is fraction. Fraction is when we are comparing parts to a whole. So for instance, we have one whole block here, the red block. Let me turn this on to my pointer so you can see. And so our fraction would just be 1 over 1 for this first block here. Now this same whole has been divided into 2 parts. So if we're looking at this part, it's only 1 out of the 2 sections, or 1 out of the 2 parts that we have divided the whole into. We divided the whole into 3 parts here, or 3 would be in our denominator, and then 4 and so forth, 5, 6. A numerator is the number that represents the part that is in the top of the fraction, and then the denominator represents the total, which is in the denominator, which is in the bottom. Product is what we get when we multiply numbers together, and quotient is what we get when we divide numbers. Reciprocal is when we take a fraction and we flip it upside down. So like 2/3 would end up being 3 over 2, for instance. And our next word, multiplicative inverse. Okay, a multiplicative inverse is 2 reciprocals that are multiplied together to create a 1. So let's look at this number. Let's look at 5. Okay, if I were to turn 5 into a fraction, it would be 5 over 1. Okay, now if I were to multiply that times its reciprocal, which is 1 over 5, my result is going to be 5 times 1 is 5, and 1 times 5 is 5. 5/5, which breaks down or simplifies to 1. So anytime you take a whole number and multiply it times its reciprocal, you're going to get a 1. Okay, and that's called a multiplicative inverse. We use that a lot when we're solving equations. Improper fractions are those kinds of fractions in which the numerator is greater than the denominator. Okay, and then a mixed number is when we have a combination of a whole number with a fraction, so like 3 1/2 or 2 1/4 and so forth. All right, our 3 lesson essential questions for today is: how do you multiply fractions by fractions, whole numbers, and mixed numbers? How do you divide fractions by fractions, whole numbers, and mixed numbers? And define what is a multiplicative inverse and provide an example. Okay, so multiplying fractions by fractions. And if you haven't yet done this, you may want to watch the adding and subtracting fractions first, because that's a little bit more challenging than the multiplying and dividing is, at least in my opinion. So you may want to do that one first and learn how to add and subtract really well before you try to do multiplying and dividing. But if you haven't, it's fine. But just know that it is different based on your operation. So again, when we add and subtract fractions, we have to have common denominators. But in multiplying and dividing, we don't have to find that common denominator. So that's a huge difference between adding and subtracting and multiplying and dividing fractions. To multiply a fraction times a fraction, multiply across the numerators first, then multiply across the denominators. You can reduce or simplify the fraction before or after multiplying. So I'm going to give you an example of this one here, 3 over 20th times 30 over 12. So here we just multiply the numerators 3 times 30, and then the denominators 20 times 12. Now this will give us a very large answer. Okay, let's go ahead and multiply those out. So 30 times 3 is going to give us a 90. And then 12 times 20 is going to give us a 240. Okay, so we can reduce this by dividing by 10. 90 divided by 10 is a 9. That should be an equals there, not a. And then 240 divided by 10 is a 24. And then we can divide it again by 3. So if I were going to divide 9 by 3, I'm going to get a 3. And then 8 divided by 24 divided by 3 is an 8. So we end up with 3/8 as our answer. So again, when you just multiply across the top and the bottom, you'll get the right answer, but it'll usually be a larger number that you have to simplify down or reduce, okay? If you reduce it before you solve the problem, this little end section here where we reduce this is going to be different. So here we are reducing it before, and that would be, we would take this, we divide 3 into this 3 and 3 into this 12, and we would get 1/4. And then here we can divide 10 into both of these, 20 and 30, and get a 2 1/3. And 1 times 3 is 3, and 2 times 4 is 8. So this is just, step 3 is something you don't have to do, but if you wanted to try to reduce it before you solve it, then that's the method. You would divide and find those common factors. Example for a second method here. Let's see. We have 4 times negative 22, and that was going to give us a negative 88. And then if we multiplied across the bottom, negative 11 times positive 8 is another negative 88. And negative 88 divided by negative 88 is a 1. Okay, so here when we multiply these, we end up with a 1 when we just multiply across the top and across the bottom. They have simplified it down, so you have a divide by 8, divide by 4, that becomes a 1, and that becomes a 2. The 11 becomes a 1, and the 22 becomes a 2. And of course, 1 times 2 is 2. And 1 times 2 down on the bottom is 2. And that also simplifies down to 1. Okay. Oh, again, they were negative 2s to start off with, because this was negative and this was negative. But the same answer is just you're simplifying it before you multiply across the top and multiply across the bottom. Okay, so multiplying fractions by whole numbers, the difference is you need to turn that whole number into a fraction first. So to multiply using fractions and whole numbers, convert the whole number into a fraction by placing it over a 1. Then multiply across the numerator and multiply across the denominator. Then reduce or simplify before or after multiplying. So here we have two examples, 2/7 times 3. So if I was going to set these up with the appropriate answer, I would place that 3 over a 1 and then multiply across the top, which gives me a 6, and then 7 times 1 is 7, and that is simplified. Again, the whole number here, 5, has been placed over 1. We multiply across the top to get a 45, and then 1 times 10 is 10. And then this one we did have to simplify. We divided by 5. We divided the numerator and the denominator by 5, okay? And 45 divided by 5 was 9, and 10 divided by 5 is 2. And then this we turned back into a mixed number. So improper fractions can be converted into mixed numbers by dividing and placing the remainder over the existing denominator. So here's an example of where we did that. We have 17 over 5, and we are dividing. 5 goes into 17 3 times, and the 2 remainder is placed on top of our numerator, or of our denominator of 5. Multiplying mixed number fractions. To multiply using mixed numbers, convert the mixed numbers into an improper fraction, then multiply the numerator across and then the denominator. Reduce or simplify before or after multiplying. So here we have 3/4 times 2 and 3/5. And mixed numbers can be converted into fractions by multiplying the denominator times the whole number and then adding the numerator and placing that over the existing denominator. Okay, so here we have an example of that where we take this 2 and 3/5 and we are multiplying the 2 times the 5 first, and then we added the 3, so that's going to give us a 13, and then that number is going to go over that existing denominator. So the denominator stays the same, it's just you're getting that numerator by multiplying and then adding. Okay. Then once you convert it, you just multiply across the numerators and then across the denominator. So 3 times 13 is 39 and 4 times 5 is 20. And then we can divide again in order to turn that improper fraction back into a whole number, or a mixed number, I should say. All right, dividing fractions by fractions. To divide a fraction by a fraction, multiply the fraction times the reciprocal of the second term. Okay, one of the rules we use, students call it keep change flip. And basically what that means is you keep the first term the same, you change the divisions to multiply, and then you flip the second fraction, the number you're dividing by, basically. You flip that one to its reciprocal. Okay, so dividing a fraction by a fraction is the same as multiplying it times its reciprocal. I'm going to say that again. Dividing a fraction dividing a fraction by a fraction is the same as multiplying that fraction times its reciprocal. So here we have 3 divided by 4, 3 over 4 divided by 2/7. And we're going to keep that first one. We're going to change that division to a multiplication symbol. And then we're going to flip this 2/7 around to read as 7 over 2. Then multiply across the top, which gives us a 21. And then multiply across the bottom, which gives us an 8. To turn this back into a mixed number, we're going to divide 21 by 8. And then our remainder is 5. So the 2 is our whole number. And the 5 is our numerator over that existing denominator, which was an 8. Keep change, flip. Okay, dividing fractions by whole numbers. To divide fractions by whole numbers, convert the whole number into a fraction by placing it over a 1 first. Then multiply times the reciprocal of the second term. So use that keep change flip method, but first change that whole number into a fraction. Reduce or simplify before or after multiplying. So here we have 2/9 divided by 3. So here we have turned this 3 into 3 over 1, okay, because we want to turn that into a fraction. Then we use our keep change flip rule, where we kept that first term, we kept the 2/9 the same, we changed our division to multiply, and then we took our 3 over 1 and we flipped it around to make 1/3. Multiply across the numerators and across the denominators, and there's your final answer. The reciprocal of a fraction is when we flip the numerator and the denominator around. Now here's where I'm going to talk about multiplicative inverses, okay? We know that an additive inverse is when we take a number and add it to its opposite. So like -4 plus +4 is going to give us a 0. That's an additive inverse. Additive inverses always give us 0. But a multiplicative inverse always gives us a 1, okay? And what we do is we take a number like the number 8, a whole number, and we place it over 1, okay? We multiply that times its reciprocal, which is 1 over 8. Okay, let me go ahead and erase it because I've already got it typed out here for us. When we multiply 8 over 1 times 1 over 8, we end up with 8 over 8, which divides out to 1 or simplifies to 1. This is true for any whole number. If you multiply it times its reciprocal, you're going to get a 1. And this is very useful. This multiplicative inverse is very useful when we're solving equations, because if we can reduce a multiple to a 1, we can eliminate certain things. So we do use multiplicative inverse and additive inverses when we solve algebraic equations. Dividing mixed number fractions. Okay, so divide using mixed numbers. You first need to convert the mixed number into an improper fraction. So you do this by doing this around the world technique that I'm going to show you in a minute. Multiply times the reciprocal of the second term, keep, change, flip, then reduce or simplify before or after multiplying. So again, we have 9 2/5 divided by 1 1/3. So I'm going to turn this into an improper fraction. The way I do that is I go around the world. I start at the bottom. That bottom number is the one we're going to keep in our denominator. So you can go ahead and write that 5 down here because we know we're going to keep it. 5 times 9 plus 2. I call it around the world because we go from the bottom to the top. So 9 times 5 plus 2, okay? 9 times 5 is 45, plus a 2 gives us a 47. That is how we turn multiple or mixed numbers into improper fractions. Okay, let's do it again. 3 times 1 plus 1. So again, 3 times 1 is 3, plus the 1 is going to give us a 4, and that's our numerator, and it goes over that existing denominator 3. Now that we have improper fractions, we can divide by using our keep, change, flip rule. So we keep the first term the same, 47 over 5. We change our division symbol to a multiplication symbol, and then we flip our 4/3 around to its reciprocal, which is 3/4. So we're, again, dividing by a number is the same as multiplying times its reciprocal. It reminds me of when you are subtracting and adding integers. Subtracting a number is the same as adding its opposite. Well, dividing by a fraction is the same as multiplying times its reciprocal. So 47 times 3 is 141, and 5 times 4 is 20. And then to turn this back into a mixed number, you need to convert it this way by using that around the world, okay? Around the world method that we did here. Or I'm sorry, to turn it back into a mixed number, we would divide. So it would be like 141 divided by 20. So 20 goes into 141 7 times, because 7 times 120, or excuse me, 7 times 20 is 140. And that's going to give us that 1 remainder. So remember, the 7 up here is our whole number. The 1 is our numerator, and then the existing denominator will go here. Okay, so let's watch out for some of these situations. When multiplying or dividing fractions that are positive and negative, the integer rules for multiplying and dividing are the same as they are for whole numbers as they are for fractions. So integer rules for multiplying and dividing, if both terms have the same signs, the answer will be positive. If both terms have different signs, the answer will be negative. So if you have not watched that integer video on how to multiply and divide integers, these are the rules. If they have the same signs, like if both are positive or if both are negative, then they will have a positive answer. If the terms have different signs, then the answer will be negative. Dividing by 0 is considered undefined in math. That means we can never divide by 0. So if you ever see a 0 in the denominator, something's not quite right, okay? We are going to talk more about this when we start learning about linear equations and slope. However, I just wanted to keep that you to keep that in mind, because 0 is allowed in the numerator. For instance, if I divide 0 by 3, my answer is 0. Okay. Any number you divide into 0 is going to give you a 0. So 0 divided by 8 is 0. 0 divided by 5 is 0. So 0 is allowed in the numerator, but as far as denominator, it is not defined in mathematics. Okay, so now it's your turn to try and grow a blossom. Our first blossom today is 5/7 times 4/5 and 1/30 times 9. So try to do that. I'm going to ask you to pause and I will count. 1, 2, 3. Okay, so the first answer there is going to be 4/7. If you got 20/35, you were close. You just forgot to simplify it. Those can be divided by 5 each in order to reduce that to 4/7. The second answer ends up being 3/10. So again, you had to remember to place that 9 over a 1 and then multiply across the top and across the denominators, and then simplify that down at the end. So if you got 9/30, you weren't wrong. It's just you hadn't simplified it down to its simplest form. Okay, let's try to grow a second blossom. This time we're doing 2 1/4 times 3 3/5. So go ahead and pause and I will count. 1, 2, 3. All right, so we need to turn these mixed numbers into improper fractions first. So 2 times 4 plus 1, remember that around the world technique. That's going to give us 9 over that existing denominator 4. Here, again, 3 times 5 plus 3 is going to give us 18 over that existing denominator 5. Then multiply across your numerators and across your denominators, and that will give you 162/20. So if you got that far, you were close, but not quite finished because you still had to simplify it, which means we got to turn it back into this mixed number here. So if you divide 162 by 20, you're going to get 8. Here, I'll go ahead and do it down here just to show you. 162 divided by 20. You're going to get an 8 because 8 times 20 is 160. Okay. And that's going to also give us a remainder of 2. And that 2 goes over the existing denominator of 20. That looks like we're finished, but there was one more step, and that is to reduce this 2/20 to 1/10, because I can divide this by 2 and this by 2. And that common factor allows us to reduce that one more time to make 8 1/10. Okay, let's try to grow our third blossom. Divide the following fractions and simplify. So here we have 5/7 divided by 4/5 and 8 divided by 2/3. I'm going to pause and ask you to try these on your own. 1, 2, 3. All right, so the first answer is going to give us a 25/28. So 5 times 4 is 5 times 5 is a 25, and 7 times 4 is a 28. I misspoke. Again, we used that keep, change, flip method. We kept the first term. We changed our division to multiply here, and then we flipped that second term around, or the number we're dividing by, to its reciprocal 5/4. The second one, this one had a whole number, so we had to place that over 1. Then we use our keep, change, flip rule again. So we kept the first term as 8/1. We changed our division to multiply, and then we flipped the 2/3 around that should have been 3/2. Hang on. That's going to give us, okay, so I had the wrong answer. See, Miss Garchow makes mistakes too. Let's see, 24/2. And 24/2 is actually 12. Okay, so if you got 12, you got the right answer. All right, our last one is divide the following fractions and simplify. So I'm going to ask you to pause and then I'll count to 3. 1, 2, 3. All right, so here we have two mixed numbers again. So we're going to around the world with it, and we're going to multiply our 4 times 2 and then add our 3. That's going to give us 11 over that existing denominator of 4. And then our second mixed number here, we're going to multiply 2 times 3, which is a 6, and then add this 1, making it a 7. Place that over that existing denominator of 2. Multiply across the numerators, which gives you a 77. And then across the denominators makes an 8. To turn that back into a mixed number, we divide 77 by 8. Remember that the n stands for numerator, and that goes in the house, okay? So just think about n when you're thinking of numerator going in the house, and then the denominator is outside the house. So 8 goes into 77 9 times. 9 times 8 is 72. And when we divide that, we end up with a 5. And that 5 is placed over our existing denominator. So 9 5/8 is our final answer. Should be 9 5/8. Got too many typos today. All right, how do you multiply fractions by fractions, whole numbers, and mixed numbers? So I'm going to ask you to try to answer this one on your own, can be in your own words, and then I'll give you the answer. Okay, to multiply a fraction times a fraction, multiply across the numerators first, then multiply across the denominators. If you can reduce or simplify the fraction before or after multiplying, turn whole numbers into fractions by placing them over 1 before multiplying them, and then turn mixed numbers into improper fractions before multiplying them. How do you divide fractions by fractions, whole numbers, and mixed numbers? So to divide a fraction by a fraction, keep the first term, change the division to multiplication, and then flip the second term to its reciprocal, the keep, change, flip rule. Then multiply across the numerators first, multiply across the denominators. You can reduce or simplify the fraction before or after multiplying. Turn the whole numbers into fractions by placing them over 1 before dividing them, and turn any mixed numbers into improper fractions before dividing them. Okay, number 3, define what is a multiplicative inverse and provide one example. So go ahead and try to answer this one. The reciprocal of a fraction is when we flip the numerator and the denominator around. A multiplicative inverse is when two reciprocals are multiplied, always giving a product of 1. Here's an example of a multiplicative inverse. Great job. All right. So let's review our vocabulary one more time. We have this awesome little owl here flying over the blossoms. Fraction is when we compare, it's a representation of parts to the whole with a numerator, which is the number on top of our fraction bar, and then the denominator is the number on the bottom. The product is when we multiply numbers together, and the least common denominator is what we use when we add or subtract fractions. A quotient is the answer we get when we divide fractions. A reciprocal is when we take a fraction and flip it to upside down, so where the numerator is now the denominator and the denominator is now the numerator. Multiplicative inverse is when we take numbers and multiply them times their reciprocal to get a product of 1. And then improper fractions are when the numerators are greater than the denominators. And mixed numbers are those numbers that have whole numbers that are attached to a fraction. Okay, great work. So a bouquet of math blossoms have opened up in your mind today. To further improve your math language skills, remember to practice and study 10 minutes daily. Ask for help if you need it. Learn from your mistakes and always try. I'm Miss G, and I want to thank you for watching Math Blossoms today. And now it's time for me to say it was lovely teaching you math today.